Hi guys, so welcome to the NFC long range data exfiltration demo. In this video I'll show you a practical way to use the NFC radio on an NFC enabled device like a smartphone to exfiltrate data out at a considerable distance. So what is a considerable distance? Well, NFC, which stands for Near Field Communications, operates on the unlicensed radio frequency of 13.56 MHz, and it's considered a short-range wireless communication technology. Its theoretical working distance is up for 20 centimeters, but the practical working distance is about 10 to 5 centimeters. NFC has several operating modes. The operating modes determines the specific kind of task that the near-field communication is performing at any given time. So I chose to use NFC type A because the signaling type uses a Miller encoding, and this technique, along with AM modulation, the signal must change from 0 to 100% strength to distinguish between binary 1 and binary 0. So I assumed this would yield a signal most likely to be picked up by a regular AM radio. So let me turn on the radio so we can check it. So right now you only listen for static, right? So when I turn on the phone, this is what the NFC probes sound like. I'm not sure if you are listening in. I'm going to grab the camera and do a close-up so we can better understand what's going on here. So when the S8 is turned on, the smartphone starts to probe for nearby tags. This means that it actively sends out a signal and tries to turn them on. Keep in mind that usually NFC tags do not have a battery, so the send signal must be strong enough to activate the tag and for it to use the signal energy and to respond to the smartphone back. So it makes sense that this probe is detected by a regular radio. This is just a cheap radio that is able to tune into 13.56 MHz. And since the phone is turned on, you can actually listen for the signal. Over here I have my oscilloscope connected to a scanner that you can actually, it's very hard to see the signal here, but you can actually see a flat line once in a while. It's not easy to catch on camera, but it's easier to listen to. By the way, thanks for the scanner, Morla. I still owe you one. So this, together with the fact that I had some previous research that allows an attacker to change the operating mode of the NFC radio without any permissions on any Android below 7.0, led me to devise a piece of Android software that would leverage this signal into a proper stealthy out-of-band data exfiltration channel. So here's the PoC. Basically it works as follows. Let's assume this device has been compromised by malware looking to exfiltrate data out in a stealthy way. For example, a password. So this device, the emitter, encodes the information and switches between NFC operating modes in a way that generates a signal that implements a practical ASK on-off keying modulation. So this proof of concept lets you choose your payload among other variables in the configuration. So let me turn off this radio here, and over here we have a measuring tape that goes all the way to 2.5 meters, where I have another radio here. It's also a standard radio, a little bit better than the other one, but able to catch on AM. You can also listen to the static here, and it's connected via the audio jack to the receiver, which is a Samsung S7 that will work on receiver mode. So right now you only hear static, so let's turn on the emitter to send some data, and you can immediately start to listen the modulation on the receiver end. So we're just going to plug in the audio jack to the receiver and click start listening. As you can see, the receiver part starts to demodulate the signal that's receiving and tries to extract the data out. So the speed isn't great. It's around 10 to 12 bits per second. This is enough to transmit your account credentials or passwords in a matter of seconds. As you can see, the measure tape marks 2.5 meters. This is like 25 times the expected distance for an NFC signal to be detected, I guess. So I think the question that follows is, how far can we stretch this? I mean, which distance can we actually detect and use the NFC radio out of a device like that? So what better way to test the range than to come outside, put a measuring tape on the ground and see how far can we still get a signal. So I positioned the emitter on my woodshed and I turn it on to transmit our secret password. So I also spread out a measuring tape which has around 30 meters, so we can see how far can we still get the signal and be able to decode it. So over here I already turned on the receiver radio and the receiver device, and we can see we are at the 10-meter mark. I hope it's possible to see. So at 10-meter mark, can actually see that the signal is still quite strong. We have some errors, but they are being mostly corrected. I can only see one error that was not corrected. And what I'm going to do is just to take the radio and take the decoder and just walk and try to figure out how long can we still get some meaningful data. So right now we are at the 16-meter mark, and it's kind of hard to do this with only one hand free, but you can see that we can still have some signal coming in, and the software is still being able to decode it, the secret password. Okay, and it's still a bit strong. It's almost at minimum power so that the software can decode it, but you can still have some signal at 16 meters. Now at the 20-meter mark, which is around here, we start to lose the ability to actually decode the signal, but there's some data coming in still. So a lot of errors now, but you can see that it's still possible to decode something. And this is mostly because of the software, not because of the signal. Let me turn the audio jack off so you can listen. See? I'm not sure if it's possible to listen, but there's still some audible interference. So let's walk a bit farther away, and you see we are at 30 meters, and I'm not sure if the video allows it to listen to, but there's some interference, and you cannot actually see those numbers on the upper right corner changing. It's the signal power that indicates that there's some signal still there, right? And we can do this up to 35 meters, and I mean, my backyard actually ends here, and there's still some little trace of audible signal there that you can see the numbers going up and down. Not sure if you can listen on the video. So yeah, NFC, you can use it to exfiltrate the data on a long range. It's 100 times more the distance that you normally expect from an NFC radio. And if you actually have some proper equipment like a AM antenna, which is directional, and instead of a radio you use an SDR dongle and you encode the proper signal, I'm pretty sure that you can increase this range for at least 2, 3, maybe 5 times more. So the outside tests showed us that we can transmit data at least 30 meters using the S8 NFC radio and have some decent receiving capabilities at around 15 meters. I also did some additional indoors testing. I had the signal travel to 2 concrete walls around 15 centimeters each at a 10 meter distance between the emitter and the receiver, and I was able to still receive the data properly. So this is still early research. Keep in mind that this is one-way data exfiltration. It's not two-way communications at all. There are a lot of immediate improvements that are possible with this method. There are still some issues to look for when testing. For example, the S7 radio, NFC radio, has a weaker signal than the S8, around 3 to 4 times weaker. But I also tested the Nexus 7, for example, and Huawei P8. They have very similar power to the S8 in terms of transmitting power. So the device position also seems to affect the range, which suggests the signal to be a bit directional, which is kind of expected. So the point is that when people think about NFC, they immediately think very short range. I mean, I did. And it's not the case. I mean, at least when sending data out this way, you can reach like 100 times, maybe even more if you had the proper equipment, the distance. So if you're just plain paranoid, or you run some kind of air-gapped facility, for example, NFC is something that you should be worrying about, and ensuring policies are in place so that devices with NFC are being properly taken care of.